So geometric sums, what we're going to be talking about here is how we identify the sum of a finite geometric sequence. A finite geometric sequence meaning that obviously we're only taking a partial sum of what a sequence works out to be, and uh, usually for something like this, we could have a common ratio of pretty much anything. There is a difference between what is a finite and an infinite geometric sequence, and a lot of it has to do with what the common ratio is and whether something converges or diverges. But we're not going to get into that right now. All we're going to look at today in this lesson is how do I find the sum, or at least the partial sum, of a finite geometric sequence. Now there's going to be a couple of things that we're going to be practicing. The rule that you see on your screen right now where it says S sub n is equal to a sub 1 and in parentheses 1 minus r to the n power, that thing is the formula that we will use to find the sum of a finite geometric sequence. Now in any time that you're going to be using this thing, you have to have two particular values. You have to have your first term, a sub 1, and you have to have your common ratio. Now obviously the common ratio can't be 1, because if the common ratio is 1, first of all, it's not even going to be a geometric sequence, because keep in mind a geometric sequence is really nothing more than an exponential function. And if I have an exponent of 1, well, that doesn't really make it an exponential function. And also simply because looking at the equation that we have here, if I have the common ratio to be a 1, well, I'd say 1 minus 1 in the denominator, which would give me a 0, and that would give me something that would be considered undefined. So we're going to be finding the sums using that formula, and we're also going to be, pardon me, using the regular the regular formula for how we express the rule for a geometric sequence to maybe determine what is the first term of something, or we might be given a list of numbers and we'll have to determine what the common ratio is. But primarily what we're going to be practicing is, can you find the sum of these sequences? So hopefully by now you have the formula copied down into your notes so that we can look at our first example. So the first one is very straightforward. It's just a simple plug and chug exercise as far as, can you put the correct values into the formula that we have. So here in this example, I want to find the sum of the first 8 terms. So I'm going to begin by just writing the general rule down. I consider it good fundamental math practices that any time that you use a formula, you write the formula down before you use it, because it'll help foster your memorization of it. You'll be able to remember it easier. So S sub n is equal to a sub 1 times 1 minus r to the n power, and divided by 1 minus r. So here we're finding the sum of the first 8 terms of the geometric sequence, and they're giving us the two things that we have to have. They're giving us the first term and the common ratio. So in this case, it's simply a matter of plugging numbers in appropriately. So if I'm going to be finding S sub 8, I'm going to replace the n with the 8. A sub 1 is given to me to be 2. And I'm going to say 1 minus r. So in this case, I'm going to say 1 minus negative 3. And I'm going to raise it to the n power. Well, n in this case, the number of terms is 8. And then I'm going to divide that by 1 minus negative 3. Now, at this point, you really can type this into your calculator the way it is. However, one thing that I have to really strongly caution students about is making sure that you do not violate your order of operations. A lot of students at this point in the numerator, where it says 1 minus negative 3, a lot of students are going to be tempted to want to say 1 plus 3 here. Okay, and unfortunately we cannot do that right now because we have negative 3 raised to the 8th power. you must take care of the exponent before I can say the negative and the negative to make it a positive. Okay, so under no circumstances here in the numerator especially should you say 1 plus 3 to the 8th power. So moving on, s sub 8. Here I'm going to say 2, and at this point I'm not going to skip any steps. I'm not going to just type it all into the calculator. I'm going to evaluate it one part at a time, just like normal. So we're going to say 1 minus, now 3, negative 3 raised to the 8th power is a positive 6,561. Well, if I say minus a positive number, that's just going to say minus 6,561. Now again, on your calculator, when you raise the negative number to an even number, meaning I'm raising a negative 3 to an 8, then we should wind up with a positive number here. But anytime you raise a negative number to a power, make sure you keep it in parentheses. Now in the denominator at this point it's fine to just say 1 plus 3 or even just write it out as a 4 because that's what it's going to wind up being. So in the numerator inside of the parentheses we wind up with a 1 minus 6561 is going to be just negative 6560 over 4, and you can see that the 2 and the 4, those will simplify to give me just negative 6560 over 2. And so s sub 8, the sum of the first 8 terms of this particular geometric sequence would be negative 3,280. So again, this is all this example was asking you to do is make sure you can substitute the values incorrectly, follow your order of operations, and arrive at the appropriate value after simplifying everything. So this example here, same idea. It's asking us to find what is the sum of the first 7 terms, but it's not outright saying, oh, these are the things that you have to plug into the formula. So here, my rule says s sub n is equal to a sub 1 times 1 minus r to the n power over 1 minus r. Well, we have to know what is a sub 1 and what is r. They're not giving us those, they're not just saying, oh, hey, these are these things. Well, a sub 1 in this case is pretty easy to identify. It is the first term in the sequence of numbers that they gave us. So 1 over 18 is r sub 1. I'm sorry, a sub 1. Now the common ratio, remember the common ratio is simply taking a number to the right. In this case, we'll say 1 over 2. And we're going to divide it by the number immediately to its left, in this case a negative 1 over 6. And that's the same thing as saying 1/2 multiplied by negative 6, which is a negative 3. So now I have the two things. I have my first term and my common ratio. So now we can substitute and find what are the sum of the first 7 terms of this particular geometric sequence. So here I'm going to say s sub 7 to show that I'm finding the sum of the first 7 terms. A sub 1 is 1 over 18. And we'll say 1 minus negative 3 again for the common ratio. We're going to raise it to the 7th power because we're substituting in with 7. And in the denominator, 1 minus negative 3. So evaluating, simplifying everything, again, the numerator, where it says 1 minus negative 3, under no circumstances should you automatically change that to a 1 plus 3, because you'd be violating your order of operations. So simplify what we can inside of the parentheses. We're going to say 1 minus, and negative 3 raised to a odd number should be another negative number. So negative 3 raised to the 7th power is going to be negative 2,187. And in the denominator, 1 minus negative 3, that's just saying 1 plus 3, so we can just write that as a 4. And just keep going, simplifying everything that you can. So inside of the numerator, we are going to say, inside of the parentheses of the numerator, rather, we're going to say 1 minus negative 2187. Well, that's going to give us a positive 2188. over 4. And at this point, this is something that you could really easily type into your calculator. Now, at some point, some of these are going to become numbers that aren't very nice fractions or decimals. Now here, if you type this into your calculator as an exact number, I'm going to get 547 over 18, or as an approximate answer, as a decimal answer, we can say about 30.389. Now, either number, the approximate number or the exact number, either one is fine. A lot of times my preference is going to be give me the exact number, leave it as an improper fraction, but sometimes the fractions, the numerator or the denominator that you're going to wind up with, because of the nature of a geometric sequence being exponential, sometimes the numbers get very, very big or very, very small, and it's not always going to be easy to write them as an exact answer. So I will take either form as long as they are the equivalent correct numbers. Now here we're going back to our summation notation. No big shocker here as far as what it's telling us to do. The summation symbol is saying take the sum of the first 7 terms of the sequence that we're given. Now here again, I have to know what is my first term, and I have to know what is my common ratio. Now in this case, the common ratio is given to you in the sequence itself to be 1 over 5. But we don't know what the first term is. So I have to figure that out. So I'm going to say a sub 1 is equal to 3 times 1/5 raised to the 1 minus 1 power. We're going to actually figure out, pardon me, when j is 1, what is my first output number? So here we'll get 3 times 1/5. 1 minus 1 in the exponent position is 0. Anything raised to the 0 power is 1. So 3 times 1 is just 3. So there are the 2 things that I need to figure out my sum. So here, S sub n is equal to a sub 1 times 1 minus r to the nth power over 1 minus r. So now substituting what we need, we're finding the sum of the first 7, so I'm going to say S sub 7, replacing n with 7. A sub 1, we figured out to be a positive 3, and we're going to say 1 minus r, which in this case is 1/5, and I'm raising it to the 7th power because I'm just substituting n with 7, and in the denominator I'm going to have 1 minus 1/5. Now I don't really know by looking at it whether the terms are increasing or decreasing now that because the base of the exponent is a fraction between 0 and 1, we know that the numbers should be decreasing over time. So the sum of the first 7 numbers, by the 7th number, it's going to be relatively small. So we'll see what kind of numbers we're going to wind up with here. So let's start simplifying the numerator. S sub 7 becomes equal to 3, and in the parentheses, 1 raised to the 7th power is 1, and the denominator 5 raised to the 7th power, that is going to be not a huge number, but a pretty big number, 78,125. And all of that is over, so in the denominator, 1 minus 1/5 is 4/5. Now in this case, some of you may be wondering, well, is it going to be better to leave it as a fraction, or do we want to put it as a decimal? Because in the inside of the parentheses of the numerator, to get a common denominator, I have to multiply the 1 top and bottom by 7125. So if I combine my stuff there, I'm going to wind up inside of the parentheses with 7124 over, or 78,124 over 78,125, which is not a very nice fraction. So at this point, it might be better off to simply take the decimal equivalents of it. So in the numerator, if I say 1 minus 1 over 78, 125, I'm going to get 3 times point, and this is a long decimal number, 9999872. And 4 over 5 in the denominator, we'll just write that as 0.8. So we'll type that into our calculator, and the rounded decimal number that we'll take here is going to be, let me change my symbol here, because we're not saying it's equal to, we're going to say it's approximately equal to 3.750. On your calculator, it tells you like 3.7499 and a whole bunch of other numbers. So we'll just round it to the nearest 3 decimals and call it a day. So there's the sum of the first 7 numbers of that one. So we've seen 3 examples so far where we're just substituting numbers and following our order of operations to find the sum of the values. The only difference is in the examples that we've seen, we started off where they said, hey, this is the first term, this is the common ratio. And in the other 2 examples, we had to figure out either the first term or the common ratio in order to do what we needed to do, find the sum. Now, here, pause the video as you need to. I'm not saying that you need to copy all of this stuff down into your notes. The one thing that you really, really need is this right here. Because what we're going to be given at some point, and that's going to be the next example that we're going to be looking at, essentially what we're going to be given is 2 points on an exponential function, on a geometric sequence. And we're going to need to use those 2 points to determine what is the common ratio and what is the first term. Well, actually, what we'll use, this right here, this rule that we have right here where it says a sub n over a sub k being equal to r to the n minus k power, that is what I'm going to use to find the common ratio in my next example. And this obviously right here, the rule for a general geometric sequence, we'll use that to find the first term. And from those 2 things, finding this first term, finding the common ratio, that's what we'll use to find the sum of however many terms that we're taking. So here we are given a sub 3 is equal to 1 and a sub 6 is equal to negative 27. And again, we're asked to find the sum of the first 6 numbers in this case. So here, if you think about it in terms of, x, y, because I continually refer to these sequences as really nothing more than a geometric, an exponential function, which is, a collection of input numbers and output numbers, x's and y's. Well, here, based on the information that they're giving me, remember the subscript number here, these are x numbers, and the answers themselves, these are y numbers. So I have 2 points. I have one point at 3, 1, and I have another point at 6, negative 27. Well, those are the numbers, those are the x, y numbers that we're basically going to be substituting into those simplified functions that we saw, or those 2 expressions that we saw a little bit ago, where I might refer to this one as let's say we'll call this one here the 3 and 1. We'll go ahead and call that one like my k point, and I'll call this one my n point, so we can see how we're going to substitute them in there. So first thing we're going to do is I'm going to find the common ratio by saying a sub n over a sub k being equal to r to the n minus k power. Now that we have that, we're going to substitute the numbers in. So a sub n, in this case, that is the output number. That's y. So I'm going to say negative 27 over a sub k, which is the other output number, a positive 1. And we don't know the common ratio. That's what we're finding. So n and k, those are representing like those are going to be the x numbers of their corresponding y values. So the x value of n, what I'm going to substitute there, that's going to be a 6. The other one I'm going to say minus a 3. So simplifying what we have here, negative 27 over 1 is just negative 27. And the exponents 6 minus 3 gives me r to the third power. Now at this point, what we're going to do is we're going to say the cubed root of r cubed and the cubed root of negative 27. Now, some of you may wonder, can I take the cubed root of a negative number? And in this case, yes. It's because the index number is an odd number, we'll still wind up with a real answer. We won't wind up with any imaginary numbers. And the cubed root of negative 27 is the same thing as saying negative 27 to the 1/3 power. So if you want to type it into your calculator either way, with the exponent of 1/3 or the cubed root of negative 27, that either way is going to give us a negative 3 to be equal to r. So there is r. There's the first thing that we needed. Now what we're going to do is find the first term. Find a sub 1. And we're going to use the general term of a geometric sequence. A sub n is equal to a sub 1 times the common ratio to the n minus 1 power. We're going to just substitute those numbers in. So that way we can figure out what the first term is. Now we have to pick. We have two input numbers, or I'm sorry, we have 2 points essentially that we can use to figure out what the first term is. And what I'm looking at are the 2 points right here, the 3, 1, and the 6 and negative 27. So those, we can use either point that we want to, but generally speaking, the 3 and the 1 is a much better option to work with because the numbers are so much smaller and simpler than 6 and a negative 27. So a sub n, that is an output number. That's a y number. So I'm going to put the 1 from, and I'm going to go ahead and use this point right here, obviously because they're smaller. So I'm going to take the y number and substitute it for a sub n because that's what the output number is. And we're looking for a sub 1. The common ratio that we got is a negative 3. And n, that's like an x number. So I'm going to say the x number of that point, which is 3 minus 1. And let's simplify and see what we get. So 1 is equal to a sub 1. Negative 3, oh, I don't know why I'm writing an equal sign here. So I'm going to say negative 3 squared. Well, negative 3 squared is a positive 9. So since the positive 9 is multiplied to a sub 1, divide it on both sides, and I'm going to get 1 over 9 to be my first term. And so now that I have those two numbers, now I can actually find the sum of the first 6, where I'm going to say S sub n is equal to a sub 1 times 1 minus r to the n power over 1 minus r. So here we're going to say S sub 6. My first term is 1 over 9. My common ratio is a negative 3, so I'm going to say 1 minus negative 3. I'm finding the sum of the first 6 power, or first 6 numbers, so I raise it to the 6th power. And so 1 minus negative 3. And quickly running out of board space here, so I'm not going to show each individual step here. 1 over 9. And in the parentheses here, we're going to say 1 minus negative 3 raised to the 6th power is a positive 729. So that gives me 1 minus 729. And in the denominator, I'm going to just wind up with a 4 again. So S sub 6. I'm going to say 1 over 9 multiplied by negative 728. And then whatever that is, I'm going to divide it by 4. So the sum of the first 6 numbers, now as a decimal, this one works out okay as a fraction. As an exact number, we'd get negative 182 over 9. Or as an approximate decimal, we would get negative 20.222 repeating. And so that's those are all of the different ways that we are going to be finding the sum of a finite geometric sequence. You have to have the first term, you have to have the common ratio, and sometimes they're given to you, sometimes you have to figure out what they are. And pretty much the last three examples that we looked at in this lesson were basically how we are going to have to find either the first term, the common ratio, or in this last example, both. So as you've been watching the video, as always, make sure that you have any questions that you have written down. Bring them to me either in tutoring or in class so that we can discuss it. And as always, thanks for watching, and we'll see you soon.